First time the B-21 lifted off the runway, every intelligence agency watching it realized the same thing. Nothing else in the bomber world even comes close. Not because of what it carried or how far it could go, but because it simply vanished. No radar spike, no heat bloom worth tracking. Just an aircraft that refuses to exist on any sensor built by any nation. While other bombers light up early warning systems the moment they climb past the clouds, the B-21 gives nothing back. Its smaller frame, cooler signature, and next-generation materials make it blend into the noise like it was shaped by nature instead of engineers. That's the difference. Other bombers announce themselves. The B-21 arrives without a trace. And by the time anyone knows it was there, the mission is already over. And the reason why will only get more unsettling from here. One thing people miss when they talk about the B-21 is that it wasn't made for the world we live in. It was made for the world that's coming. Most aircraft age the way people do. They're born strong, they pick up issues over time, and eventually the technology around them moves faster than they can be upgraded. You can see it clearly in the B-52. You can see it in the Tu-95. Even the B-2, which was cutting edge in the 90s, now needs constant updates just to stay afloat against modern radar. The B-21 is different. When you look at its layout and the way the Air Force keeps describing it, you realize it was designed almost like a piece of software. Everything inside it is modular. The processors, the sensors, the data pathways. It's all meant to be swapped, extended, or expanded without having to tear open the airframe. Engineers keep calling it open architecture, but the phrase undersells what that actually means. It's more like giving the aircraft room to grow into threats that don't exist yet. That's why the Air Force compares its upgrade cycle to modern software rather than traditional aircraft modernization. Its stealth materials reflect the same philosophy. Older stealth aircraft require a level of care that borders on obsessive. Temperature, humidity, how long they sit outside. A simple repair can take hours because the coatings are fragile and layered like glass. The B-21's skin is a different story. The composites were built with durability in mind, not just low observability. Ground crews say it behaves more like a normal aircraft. Wash it, inspect it, fly it again. No ritual, no babysitting. And this leads to a quietly unsettling point. If an aircraft is designed to accept new computing power, new sensors, and new weapons without being rebuilt, what does it look like 10 years into service? What does it become? It's the first bomber built with the assumption that the threat environment will keep shifting faster than hardware can. The B-21 doesn't fight that trend. It leans into it. And that's the doorway to the next question. If the bomber keeps evolving, how do you measure its power at any single moment? You can't. And that's exactly the problem for anyone trying to counter it. To understand why the B-21 scares defense analysts, you have to forget the usual checklist. Range, payload, survivability. They matter, but they're not the heart of the story. The real advantage lies in how the aircraft understands the world around it. Everything about the Raider is built around sensing without being sensed. Modern air defense systems rely on stitching together radar, infrared, networked listening posts, and airborne warning platforms. They create a kind of overlapping picture of the sky. The B-21's job isn't just to slip through those layers, it's to quietly read them. Inside the aircraft is a collection of passive and active sensors that track electromagnetic activity in ways the Air Force openly refuses to detail. It doesn't broadcast much, but it listens constantly. Small shifts in radar frequency, changes in infrared temperature, gaps in a data link. The B-21 organizes all of it into a coherent picture in real time. Pilots have described it off the record as flying inside a bubble of information, where the aircraft is always a few steps ahead of whatever is searching for it. That kind of awareness changes how a bomber behaves. Instead of plotting a straight line and hoping its stealth works, the B-21 can drift through weak spots as they appear. It can time its movements around radar rotations. It can map entire air defense grids without tipping anything off. And here's where the unease starts to creep in. The information it gathers isn't just for itself. The B-21 is connected to the same digital backbone that ties together fighters, satellites, drones, and ground forces. Whatever it learns is immediately shared across the force. A radar site that thinks it's operating quietly might get exposed to a half a dozen aircraft it didn't even know were nearby. All because the B-21 heard a signal pattern that no human operator would have noticed. It flips the dynamic of modern warfare. A stealth bomber used to be something you hid until the moment you needed it. The B-21, ironically, becomes more valuable the deeper it moves into enemy airspace long before it drops anything. Picture a future conflict in the Pacific. An enemy carrier group believes it's operating under a protected radar umbrella. What it doesn't realize is that a B-21 has been silently mapping every node in that network for hours, feeding targeting data to platforms hundreds of miles away. And that leads to the next natural question. If this is what the aircraft can do before it even opens its weapons bay, what happens when it uses systems that no bomber has carried before? The B-21's weapons bay is one of the least understood parts of the aircraft, and that's partly intentional. On paper, it's described with a bland phrase: flexible internal volume. In reality, that phrase hints at something far more unusual. The bay wasn't designed around a fixed weapons family. It was shaped around the idea that the weapons it carries in the 2030s and 2040s might not exist yet. Older bombers were built around specific payloads. The B-52 depends on external hardpoints. The B-1 relies on massive internal bays sized around Cold War-era missiles. Even the B-2 had to be modified each time a new precision weapon came along. The B-21 works differently. Its bay has a variable mounting grid and a wiring infrastructure that allows technicians to reconfigure it the way IT departments reconfigure server racks. It's closer to a modular workstation than a traditional bomber. The Air Force has already hinted at several categories of weapons the Raider will carry early on. Standoff cruise missiles like the JAS-SMER family. Penetrators designed to break into fortified underground structures. The long-range standoff nuclear missile, once it becomes operational. These alone would give the aircraft capabilities beyond anything in current service. But they're only the recognizable items on the list. What's tucked into the budget files is more revealing. Several line items refer to classified air-launched programs with advanced propulsion. Those usually point toward air-breathing hypersonic prototypes, the kind that can maneuver during flight rather than follow a predictable ballistic path. The B-21's geometry, with its long center section and deep root volume, would allow it to house these weapons without reshaping the airframe. There's also talk among engineers about effects-based payloads, systems that don't explode but disrupt, electronic intrusion pods, directed energy modules that interfere with targeting systems, compact jamming units that collapse enemy sensor networks from inside the perimeter. Placing those inside a fully stealth aircraft is the sort of design choice that changes entire war plans. A platform that can fly deep into defended airspace and quietly disable the sensors meant to detect it doesn't need to drop much. It simply unravels the defenses from within. The most revealing detail is how Northrop's engineers describe the bay: future-weighted. Not future-ready, but future-weighted. Meaning the aircraft's most important payloads are the ones the public hasn't heard about yet. It's a space built for technologies that only become possible when you assume the bomber itself won't be detected while deploying them. As a result, the B-21's offensive capability isn't fixed. It's something that expands the longer the aircraft stays in production. No other bomber has been designed with that kind of elasticity in mind. And it's the reason defense analysts struggle to define the Raider's full combat ceiling. The ceiling isn't visible yet because the aircraft was designed to grow into it. But what does a bomber become when the world's most advanced weapons are designed specifically for its hidden interior? Modern air defense networks rely heavily on infrared tracking. Radars can be fooled or saturated. Radio frequency sensors can be jammed or decoyed. But heat is harder to fake, which is why thermal satellites and long-range IR cameras have become so important. An aircraft might hide from radar, but the glow of its engines often gives it away. The B-21's designers spent as much effort controlling temperature as they did shaping the airframe. Its cooling system isn't built around one trick. It's a collection of small engineering decisions that, when layered together, lower the aircraft's thermal footprint in ways that aren't obvious at first glance. The engines sit deep inside the wing root where the hottest sections are hidden from open air. Air is pulled in through carefully shielded inlets, mixed with cooler flow, and exhausted through ducts that spread the heat across a broad, insulated path. That wide dispersion prevents the single, bright plume that traditional sensors look for. The B-2 had a version of this concept, but composites have advanced to the point where heat can now be soaked, diffused, and released with far more subtlety. The outer skin contributes as well. Some of the composites absorb heat, some resist it, and others radiate it more quickly. Together, they smooth temperature differences the way a sound engineer smooths out sharp spikes in a recording. The result isn't an aircraft that runs cold. It's an aircraft that avoids abrupt thermal contrast, which is what satellites and tracking pods rely on. There's also the engine itself. The B-21 uses a derivative of a commercial core known for high efficiency and cooler operation. Lower fuel burn means lower temperatures, and lower temperatures mean fewer infrared signatures to track. It's a simple principle, but in stealth design, simple advantages compound into larger ones. Maintenance procedures help too. Earlier stealth aircraft required meticulous care to prevent panels from trapping heat or warping under stress. The Raider's materials tolerate environmental conditions far better, which keeps thermal performance consistent from flight to flight. Consistency matters because unpredictable hotspots are often the first things sensors detect. Put all of this together and the result is an aircraft that rarely appears as a clear thermal object. Analysts who've reviewed early imagery describe it as a soft shape, a faint patch, not a defined profile. In infrared space, where most aircraft shine like headlights on a dark road, the B-21 comes across more like a dim piece of sky. This level of thermal discretion affects more than survivability. It changes how the aircraft can be positioned and how long it can linger. Long-duration intelligence flights, precision insertions, electronic support missions. Tasks that normally come with significant detection risk become viable because the bomber doesn't betray itself through heat. In the broader picture, this means adversaries can't rely on their most trusted sensor layers to pick up early movement. Even if radar misses it, infrared should be the fallback. With the B-21, that fallback isn't reliable anymore. And that shifts the balance of high-end air defense in a direction no country is comfortable with. Most people imagine electronic warfare as loud, aggressive interference. Radar jamming, scrambling frequencies, drowning out communications. That's the way it worked during the Cold War, when overwhelming the enemy's sensors was the primary strategy. The B-21's approach is almost the opposite. Instead of blasting signals into the air, it works in a far quieter lane, detection shaping. The aircraft is constantly scanning the electromagnetic spectrum, but it does so passively, almost as if it's listening instead of searching. Modern air defense networks rely on radar sites, data relays, airborne nodes, and ground stations that all speak to each other digitally. These digital conversations create patterns, timing intervals, modulation quirks, signal gaps that tell an experienced system how the network is structured. The B21 reads those patterns and maps them in a way that resembles a living diagram of the entire defensive grid. Once it understands the shape of that grid, it begins adjusting its own electronic profile. Not a broadcast, not a jam, but a subtle alteration of how its systems respond to external signals. Older stealth aircraft tried to hide by minimizing emissions. The Raider goes a step further. It tailors what tiny emissions it can't avoid, so they blend into the background noise of the environment. Nothing stands out, nothing spikes. The aircraft's signature becomes a statistical outlier, technically present but indistinguishable from clutter. There are early signs that the Raider will eventually support more active capabilities when needed. The Air Force has been investing in compact digital attack modules small enough to be mounted internally, and the B-21's architecture is designed to accept them without major redesign. These aren't brute force jammers. They're targeted tools meant to interrupt specific nodes inside a network, creating pockets of confusion rather than system-wide chaos. This approach mirrors modern cyber strategy more than traditional aerial jamming. Quiet disruption, clean entry and exit, no obvious fingerprints. An aircraft that can do that inside contested airspace turns defensive networks into unstable systems. Operators lose confidence in their readings. Intercepts are delayed or misdirected. And because the disturbance isn't loud, there's no clear moment when defenders can say, "This is when the attack started." The degradation feels like internal malfunction. For a bomber, that level of electronic subtlety allows it to operate deeper, stay longer, and coordinate more tightly with other platforms. It also changes how adversaries think about their own systems. When the failure point is invisible, everything becomes a potential vulnerability. The uncertainty itself becomes the weapon. Stealth aircraft have always had one major weakness: they're difficult to maintain. The B-2's skin requires climate-controlled hangars, specialized tools, and teams of technicians trained specifically for low observable upkeep. Older stealth platforms often required up to 50 to 60 maintenance hours for every flight hour. The B-21's projected ratio is dramatically lower, though the exact figure remains classified. Every hour in the air could mean dozens of hours on the ground. That logistical burden limited where the aircraft could operate and how quickly it could turn around. The B-21 was engineered to break that dependency. From the beginning, the Air Force insisted that the aircraft had to be maintainable at bases that don't have perfect weather or elaborate infrastructure. To meet that requirement, the designers had to rethink the problem at the material level. The composite layers are more durable, the coatings don't peel when exposed to moisture, and the panel system is structured so that technicians can open and reseal access points without compromising the low observable surface. This doesn't eliminate maintenance, but it changes its character. Instead of intricate reconditioning work, crews can focus on standard inspection cycles. Ground teams don't need the same hyper-specialized environment that earlier stealth platforms demanded. This alone widens the set of global bases that can host the aircraft, which matters more than it sounds. A bomber with a smaller maintenance footprint doesn't depend on a handful of bases for survival. It can disperse, reposition, and stay unpredictable. The power system benefits from this philosophy too. Efficiency isn't just about fuel burn. It affects reliability. Cooler running engines put less strain on surrounding materials, which translates to fewer sensitive components reaching their temperature limits. Less strain means fewer early failures. The B-21's electrical systems are built around standardized modules that can be swapped quickly without shutting down entire subsystems, a design choice borrowed from commercial aviation. Even the software supports the logistics strategy. Instead of requiring aircraft to undergo long update cycles grounded in hangars, the B-21 was built to receive incremental upgrades more like a modern ship or satellite. Small improvements delivered frequently, rather than major overhauls every decade. Over time, that keeps the fleet consistent. Older airframes don't spiral into obsolescence. Newer ones don't leap too far ahead. The whole inventory stays aligned. The strategic effect of all this is subtle but significant. A bomber capable of deploying from more locations is harder to plan against. A bomber that recovers faster after each mission can be tasked more often. And a stealth platform that doesn't drain manpower simply by existing becomes a realistic tool for sustained operations, not just rare, high-priority missions. In the long run, this is what changes force posture. The aircraft becomes less of a museum piece and more of a daily instrument. That's a shift no adversary wants to see, because it means the United States can maintain stealth presence without exhausting its own resources, a luxury not every country has. As the B-21 moves from early testing into the first stages of operational life, the most striking thing about it isn't any single feature. It's the way the entire aircraft seems built around longevity, not just physical durability, but strategic durability. The ability to remain relevant even as the character of warfare shifts. This wasn't a luxury for the designers. It was a requirement baked directly into the program from the first briefing. The United States no longer assumes future conflicts will resemble the ones that shaped older bombers. Long-range precision weapons, satellite networks, cyber intrusions, and layered denial systems have changed the map. Instead of building a machine tailored to today's environment, the engineers built something that can adapt to the next version of it. The internal computing backbone can absorb new processing loads. The airframe leaves room for weapons that haven't reached flight testing. The sensor suite isn't tied to one method of detection or one interpretation of the battlefield. This gives the B-21 a type of stability older fleets never enjoyed. It doesn't grow obsolete on a fixed timeline. It evolves by design, not by emergency retrofits. And because its logistical demands are lighter, the Air Force can afford to operate it continuously rather than reserving it for rare, symbolic missions. Over time, that normalizes the presence of a platform that was once reserved for the highest stakes operations. Behind the scenes, planners are already treating the Raider as a central piece of the long-term force structure. Its survivability allows commanders to treat it less like an asset that must be protected and more like an asset that shapes the environment around it. In a sense, it becomes a stabilizing tool, something that can quietly move through contested regions, gather information, support allied forces, and signal capability without escalating a situation. This is the part of the story that rarely makes headlines. The B-21 isn't just a bomber, it's a strategic anchor. Its very existence forces competitors to reconsider how they deploy their defenses, how they allocate their budgets, and how they structure their long-range detection networks. They can't afford to ignore it, but they also can't afford to chase every possible direction the aircraft might evolve toward. The story of the B-21 isn't really about dominance or headlines. It's about an aircraft built with a level of patience and long-view thinking that's rare in modern defense programs. Everything about it feels deliberate, meant to last, meant to stay useful, meant to give commanders options other systems can't. Years from now, when much of today's technology feels outdated, the Raider will still be shaping decisions in quiet ways. If you'd like more breakdowns told in the same straightforward style, feel free to stick around and follow the channel for the next deep dive.